So welcome everyone to our review session number 3, which will be on lesson 8 of the summer term, principle of addition and multiplication. Right, so the first part will be quite simple, the principle of addition. That's quite easy, so we're going to spend a lot of time on the principle of multiplication. So when do we use principle of addition? This is when we have an either-or scenario. So then we add up the choices. We'll have a look at some examples and it will make it a lot more clearer. And when do we use this principle? When all the choices lead to the completion of the task and we can use any one of them. So what that means is, if we're given a few choices, so for example, let's suppose I want to play a ball game and I can choose between 2 basketballs and I can choose between 4 different kinds of footballs. Imagine they're different colours. I just want to pick one ball, so I will have 2 plus 4, 6 choices. And that's when we use principle of addition. So we need to think about our end game. So when we're our end point, what are we trying to achieve? Read the question. The question will usually give a clue. We have to choose either this or this, and it's quite apparent sometimes. Someone's raised their hand. Hello, Lucy. Let me try to find the person who raised their hand. Hello, Connie. Okay. If you've raised your hand, can you just raise your hand again, please? Okay, I can't see you again on the chat, but do let me know on the chat if you have a question. Let's move on to some examples. So these are taken from the lessons, or they're also taken from the stage test, which I hope everyone has had a look at. So Danny finds 5 snack bars, 2 Chinese restaurants, and 1 coffee house around her neighborhood. If Danny wants to choose one of them to have her lunch, then there are in total how many different choices for her to choose from? So again, the objective is for Danny to go and have lunch. And she can achieve that task by going to either one of the 5 snack bars, or 2 of the Chinese restaurants, or one coffee house, the only coffee house. So that's when we add. Principle of addition, we're adding. So if it doesn't matter where she goes, if there's no first and next step, if they're all independent choices, then we just use principle of addition, just adding. So 5 plus 2 plus 1 is 8. So there are 8 different choices for her to choose from. Is that okay for everyone? Oh, if you're speaking Chinese, I don't speak Chinese. Okay. Okay, thank you, Nicholas, for the thumbs up. Right, any questions at all? I'll wait for a minute. Thank you, Harry. A nice authoritative figure. Okay. Stop chatting. Okay. Right. I'll use the chat only if you have questions. So anytime I'm pausing, I will have a look at it, and that will delay us a little bit. But it's important to know that everyone understands. This is our final principle of addition question in today's revision session. So question number 2. Yes. Addition is easy. Is that Oliver I'm speaking with? Yes, a principle of addition is easy, so we're quickly going to go through that, and we want to focus on principle of multiplication. Okay, Oliver? Right, okay. So there are 3 soccer teams in a 4th grade gym class. Each team has 18, 20, and 16 boys respectively. If one boy is randomly selected to be a soccer captain of the 4th grade, how many ways can a captain be selected? So again, we just want to select one boy to become the captain. And with that task can be achieved by selecting that boy from either 3 of the groups. And each group has a different number of boys, so either from the first team, that's 18 boys, we can choose 1 boy from there, or from the second team, which has 20 boys, or from the third team, which has 16 boys. So we just do the addition and we get 54 choices. There are 54 choices to choose the captain. Okay, so principle of addition, super simple and easy, right? Okay, yep, thank you very much, Adita. Let's move on to principle of multiplication. So the key points for principle of multiplication. In a first to next scenario, we use the principle of multiplication. So we use multiplication or times between the numbers or the different choices to find the number of combinations. So in previous lessons, we've just listed out how many different options we have, but we want a better way to do this. We want a quicker way to do this. So when do we use this principle? We use it when different choices lead to the completion of the task and we have to choose them step by step. So the reason why we call it first next, from the question we can understand, do we have a first step and then do we have a next step? So it could be first then or first next. So first we have to do something, then we have to choose another thing. And in each step there are a different number of achieving a task. There's a classic example. I'll go to the board for principle of multiplication. If we go somewhere and we want to select a combo meal, and a combo meal means 1 main and 1 drink, and the choices are 2 burgers, there's a cheeseburger option, there's a veggie burger option, and 3 drinks. We can choose from 3 drinks: cola, juice and water. So first we have to choose it between the 2 burgers, then we have to choose between the drinks. So again, the question, you have to read the question and understand it. Is it asking for first and next, or is it asking for either or? So ask yourself, when we want a combo meal, do we just want any one of these items? No, we want first a main meal, one of the burgers, then we want a drink. That's when we use principle of multiplication. So, right, I've listed them all out. So if we choose the cheeseburger, we can have a cola with it. If we choose the cheeseburger, we can have a juice with it. And then we can also have a water with it. So 3 options for the cheeseburger. So for one type of burger, there's 3 options. And then same for the veggie burger, there's also 3 options. So 3 plus 3 is just going to be 6. 6 options. As I said, I've listed them out. The way we can do it with principle of multiplication is we say, I'll go back to this page here. The way we can do it is we have 2 burgers. So for each burger, we have 3 options. That's why it's 2 times 3. That's where principle of multiplication comes in. And I don't want to bore everyone, but that is the basics. So if we understand that, we will be good to go and we can solve these questions. So just to recap, what's the difference between principle of addition and principle of multiplication? From the question, and sometimes it's not obvious, but sometimes we're given principle of addition. Look in the question, does it say anywhere either or? So if you understand that, then we use principle of addition, so we add up the choices. If the question says we need to choose between this and that, so if it says and, that's when we use principle of multiplication. We do times. Okay, any questions? I think there's someone on the chat. Oh, Bella's gone, I see. Okay. Okay, so let's have a look at some examples. First, we're going to practice the principle of multiplication, then we're going to go on to some trickier questions. So, in my suitcase, I have 5 sweaters and 6 pairs of trousers. If I make an outfit of a sweater and a pair of trousers, so it's not just choosing one item, we need to choose a sweater and a pair of trousers. How many different outfits can I select? So again, I've underlined the and because that's when we use multiplication, principle of multiplication. For each of the 5 sweaters, we can pair it up with 6 different pairs of trousers. This is why it's 5 times 6. and there are 30 options, 30 different outfits I can select. Okay, everyone happy with that? Everyone's playing around with the filters. Okay. Oh, hello Jensen, hello Nate, welcome. Haven't said hello to you. I think I've said hello to everyone else. Oh, Oliver, do you have any questions? You've got your hand up, I think. No? Okay. Right, so let's now move on. Okay, so Nini prepares some gifts for grade 2 students. A student can choose either a football or a basketball or a football, and a balloon of 4 different colours: red, yellow, blue and green. How many different choices are there for each student? So this is now a mixed scenario. And how do I know it's a mixed scenario? So what do I mean by mixed scenario? I mean we have principle of addition and principle of multiplication. So how do I know this is a mixed scenario? It's because a student can choose either a basketball or a football. So this is the principle of addition. We know that either or is addition. And so remember what happens with and. When we have and, we do principle of multiplication. So the student has to choose not any one of these items. First, the student needs to choose between a basketball and a football. So basketball and football, there are 2 options: basketball and football, or a football. So that's 2 options, 1 plus 1, 2 choices there. So this is first choosing between a basketball and a football. Then, and the final step is to choose between 4 different colours for a balloon. So that's 4 options. Okay, first, then, so we have to do times. So 2 times the 4. So 2 times 4. There are 8 options. There are 8 different choices for each student. So with these questions, it's important to understand which part is either or and which part is first and next. So the either or is either between a basketball or a football. So that's 1 plus 1, 2. And then either any one of these colours for the balloon. So 4 options for the balloon. And then we say first choose between the balls and then the balloons. So that's what it's 2 times 4. Okay, any questions at all? No questions? No questions, okay. No questions, okay, Maya, thank you. Right. I'll move on then. This might be quite a short revision session then, if no one has any questions. So another mixed scenario. Okay, so acceleration students, you might not have seen these questions because that wasn't part of the lesson. So you can just skip to the other questions if you want to, but if you just want to sit and listen, that's also fine. But these were a part of the mastery class and the competition class. Okay, so how many different paths are there from A to G? So we need to go from A to G. Okay, and we can already see there's so many paths. We can't just list them all out. The reason why we're doing this maths is because we want to avoid listing. Okay, so can everyone see there's a top path, there's a middle path, and there's a bottom path. So if we just think about sections, there's a top route to get to from A to G, then a middle way to go from A to G, and then a lower way to go from A to G. And in a more mathematical term, we need to define the points. So when I'm talking about the top, I mean going from A to B, then to C, then to G. So notice what I'm saying. First we go from A to B, then B to C, then C to G. So if it's first, next, what do we use? Times or adding? Times, thank you very much. We're going to be doing times. So between A to B, first A to B, how many choices? There are 3 choices. You've correctly told me there's times, so we're going to times. And then B to C, does anyone want to tell me how many options for B to C? Just unmute yourself. 4, perfect job. B to C is done, then C to G. Anyone brave enough? 2, perfect job. And G is our last point, so we stop there. 3 times 4 is 12, times 2, 24. And again, you can list out how many different options there are, and you will find that from the top here, there are 24 options. And we found that mathematically. There are 24 ways to go from A to G using the top route, so A to B to C to G. Okay, everyone happy with that? I'm just going to do a quick check. Yes, thank you very much. And now I'll just move on to the middle part. So does anyone want to tell me what the middle route includes? What are the points in the middle route? A to D, E, G, perfect job. So A to D, then to E, and then to G. Okay, so A to D, that is 2 options. We times. D to E, I can see 4 different routes, and from E to G there are 3 different routes. So 2 times 4 times 3, that's 8 times 3, that is also 24. So there are 24 different routes going from A, D, E, G. Okay, and we just have to do that for the bottom one. We're going from A to F and then straight to G. So only 3 points there. A to F, I can count 1, 2, 3, 3 routes there, and F to G, that's 1 route, but we also have to, we always have to include that. 3 times 1 is 3. And the final part is just adding those up, because remember, we're either taking the top route, so it's either the top route or the mid route or the bottom route. So either or we add up. So we have to add up all these different options. 24 plus 24 plus 3 is 51. Okay. We're going from A to G. And follow the arrows. There's no turning back. It's one way. Edita, is that okay? They're not connected. Can you see? Between D and B, there's no routes. Is that okay? Yeah. Again, follow the arrows, follow the paths. Okay. Any other questions? Let me see the chat. Yep, perfect job, Elaine. Very well done. Okay, and we're just going to do one more practice on that, I think. Yep, one more practice on that. So Mike runs a restaurant and sells 3 kinds of hamburgers, 2 kinds of fries, and 3 kinds of sandwiches. If you can choose 2 kinds from any 2 food items to make a combo, 1 kind of each food, how many different combos can you make? Okay, so there are 3 different items, hamburgers, fries, and sandwiches. And this time I'm not going to write them out. I'm just going to name them, or letter them H, F for fries, and S for sandwiches. Is that okay? So everyone understands what I'm doing here, right? Just to save time. There's someone with Chinese writing in their name and they've got the hand raised. I'm not too sure who that is. Okay, no worries. Oh, okay. So that was probably for your previous question. Right, okay. 69. Where's the 69 coming from? Oh, is it when you were going from... Yeah, when you were going from D to B, probably. Okay. Right, so we need to make a combo. A combo means combining two different kinds of food items. So let's list that out first so we can remember this is either or. We're creating the combos. Does anyone want to come up and give me a combo of two items, food items? No one's brave enough to come up. Who would like to give it a go? Okay, I'll start. Okay, so we can combine a hamburger with fries, and that will make us a combo meal. So we can choose between hamburger and fries. So it's and when we have and, it's principle of multiplication. For each of the three kinds of hamburgers, we can choose between two different fries. So we can combine it with two different kinds of fries. That is 6 options for hamburger and fries. Okay, so we can have that combo meal, or we can do another combo meal. So not hamburger and fries. Can anyone give me a different kind? Sandwich and fries, very nice. Sandwich and fries, let's try that. So again, how many kinds of sandwiches are there? Oh, okay. I'm going to not allow annotating, if that's okay. Oh, okay. Right. Sorry. Yep. If you annotate, the board will get messy. But if you want to give it a go, just raise your hand. So I've just switched it off because it might just get a bit messy. But raise your hand, and I'll try to bring you up. If you want to do it, of course. Okay. Oh, Harry, do you want to give it a go? Okay. So Harry... Oh, hamburger and sandwiches. Okay, so you're giving me a different combo. Right. Yep, I don't use Zoom, so this is all a bit new to me. Okay. Right, I think I've got the hang of it. Please don't mind me. Okay. Right, okay. So sandwiches and fries. I did see a 3. You're absolutely right. There are 3 kinds of sandwiches, and we can combine that with 2 kinds of fries. So 3 times 2, that's another 6. Harry, you told me. Or we can choose hamburger and sandwiches, which sounds a bit weird, but that is definitely a combo. Let me write that a bit neater. Hamburger and sandwiches, again, so 3 kinds of hamburgers to choose from, and we can combine each 3 with 3 kinds of sandwiches. So 3 times 3, that's 9 options. Are these all our combo meals? Maya's giving me a thumbs up. Perfect. Very well done. Yep. Because it's either or now, all we have to do is just add them up. So 6 plus 6 is 12, plus the 9 is going to be 21. So the answer would be D. Okay, so that's the end of our mixed scenarios. Does anyone want me to go through one of these questions again? Yeah, perfect job, Adita. I think that's you. Okay, if not, we'll move on to the last part, which the acceleration students you all had. So I think, who's here from acceleration? Just Fiona? Yep, I think just Fiona. Okay, perfect. Okay, we'll carry on then. Okay, so we've only got 2 questions left. Today is Amy's birthday, and this was taken from the stage test. Today is Amy's birthday. She takes... Easy, Leanne? I'm glad you find it easy peasy. So today is Amy's birthday. She takes photos with her 4 close friends. All of them stand in a line, and they make Anne stand in the middle. There are how many different ways for them to form the line? Okay, since it is easy, Maya, you've raised your hand. Just going to Maya. Yes, Maya. That is a very good question, actually. I do not know the answer to that. I think Amy feels safer to be on the side. Anyways, let's guess Adita. Yes, we'll move on. Okay, so how many people are there? How many students are there? How many friends are there? Sorry, not students. 5. I can see Adita's 5. Thank you very much. Okay, 5 students. So we've moved on to queuing up problems or taking photo problems, standing in a line problems. So 5 friends. Let me write that up here. 5 friends. Okay. Is that you, Leanne? Yes, okay, of course you can. 8, okay, thank you. Let me see if I also get 8. 5 friends. So the way I do it is I always draw out the spaces. You did it in reverse. Sorry, I couldn't hear that. Oh, you did it really quickly. Okay, fantastic job. I take it quite slow. I like to draw out the spaces. 5 of them. It is Amy's birthday, as Maya has pointed out, but they make Anne stand in the middle. So if Anne stands in the middle, that's only one option for her to stand in. So the third position, the middle position, can only be taken up by one person. So if we look at the second person, so since it is Amy's birthday, let's suppose Amy. Amy now has 4 options, 4 choices to stand in. So she can fill in any one of these positions. So there are 4 options for Amy. Okay, let's suppose Amy has chosen... Actually, let's suppose she has chosen the one next to Anne. Now that leaves 3 options for the next friend. Okay, and again, let's suppose the third person has chosen this place. It leaves 2 options for the 4th person, and then 1 more option for the last person. So it's 4 times 3, 12. Yep, 12 times 2, 24. Okay, so Leanne, let me know if you understand that now or you agree with that now. Okay, do you understand what you did wrong now, Leanne? Okay, so is it okay now, Leanne? Yep, perfect. Does everyone understand what we're doing here? Okay, nice nods. Perfect. If you ever have any questions, do please let me know. Okay, so we have only 1 more question, and then that would be the end. And then we are finished. I think you're all just a bit too clever to be having this revision session. Adita, yes, it was 24. Okay, so again, there are 5 people. 5 students are lining up to take a picture. So draw out the 5 positions. Jessica is standing in the middle. So Jessica is standing in the middle. So how many options are there for Jessica? Anyone? 1. Very well done, Connie. Thank you very much. 1. Thank you, Leanne. 1 option for Jessica. Ian is standing on either end. So Ian has how many options? 2 options for Ian. Yep. But let's suppose Ian only takes up this position. So even though Ian has 2 positions, he can't be standing on both ends. So he will take up one of these. The other place is open now. So the third person will have how many options? 3. Thank you, Leanne. So again, let's suppose the third person has taken up this position. For the 4th person, how many options left? 2. Thank you very much. So 2, and then, thank you, Elaine, and the final person has only 1 option left. So it's 2 times 3 times 2. So 6 times 2 is 12. Yes, thank you, Leanne. So there are 12 ways the students can line up. Very well done. Fantastic job. Unfortunately, I cannot give coins. Oh, very well done. So Is there anything I haven't explained that anyone would like me to explain? No? Okay. So you can leave because I have no more questions for you, actually. So very well done. Bye, Leanne. Thank you for joining. No, thank you for coming. Bye-bye. Thank you. Lovely to meet you all. Bye-bye. If you do have any questions, I'll stay for a bit longer. Bye-bye, Maya. Bye, Nicholas. Bye, Nicholas.